Well, hello everyone. Today we are going to look at applications of quadratics, and what I'm going to be doing is setting up some questions and then basically talking you through how you would solve these types of questions. So first one we're going to look at is one where you're told, so this basically is a version of question 1, where you're told the position S of an object and it's given the way you might see it in a physics class. So at any given time t, the position S is some number v0 t, take away 16t squared, and v0 is a specific number and it's the initial velocity. So in this question, you are told that the initial velocity was 216 and the units happen to be feet per second. So this formula really could have been simply just written as 216t take away 16t squared. And we are being asked to find the time for this projectile to eventually reach the ground. If you put this into some software, you would find out that if you made this time in that position, it starts off, shoots into the air, and then lands. And we want to find that time. So that's our goal. So what do we have to work with? Well, we know its position, which is 216t, take away 16t squared. And since it's hitting the ground, we know its position, if you like, its height, will be 0. So I'm now having to solve this equation here. And I'm going to try and do it, if I can, by factoring. So I know I can pull out t as a common factor. I'm wondering if I can pull out 16. And almost. What about 8 then? Yeah, I can pull out 8. So if you pull out 8t as a common factor, you're going to be left with 27 take away 2t equals 0. Now, since I'm solving this quadratic equation by factoring, I have 2 factors, and we're looking for the value of t that makes this factor 0, which is pretty obvious. And then this one here, we need to find the value of t that makes that guy 0. And so, well, you can solve it various ways. How about subtracting 27 from both sides, and then dividing both sides by -2. And in this case, the answer that they're looking for is this one. So that guy there would be 13.5 seconds. And that's our first application. If we move on to our next situation, we are given, this is question 2, we're given the same basic starting value. And we're told that V0 is 216. And we're being asked, let me redo that, we're being told that this is 96. That's better. So essentially, our position function will be 96t take away 16t squared. But this time, we're not being asked when does it hit the ground, right? When is position 0? We're being asked to solve when is its position, its height. Equal to, let me find out for a minute. When is its height? 144 feet. So we are trying to solve when is its height, its position, 144. So we are trying to solve when is this guy, take away this guy, equal to 144. Now in this particular equation, it's definitely a quadratic, but it's not very, well, usable. So I'm going to rearrange it so it's in its standard form. And I'm going to subtract 144. And now I have the whole quadratic equal to 0, which is this guy here. Now, if I wanted to solve this, I could try and factor it. I think you'd have a really hard time getting it to factor. So I'm not going to do that. I'm going to do the formula. So A is -16, B is 96, and C is -144. Then I'm going to use the quadratic formula, but before I do that, I'm going to calculate that piece, which is 96 squared, take away 4 times -16 times -144. And that's definitely for a calculator. Let's see what we get. 96 squared, take away 4 times -16 times -144, and the answer I get is 0. Oh, okay. So t instead of x is -b plus or minus the square root of b squared take away 4ac all over 2a. And this guy is going to be negative of him, so -96. Add or subtract 0, which is quite interesting. All divided by 2 times that guy is -32. And what we get here is just one solution, and it happens to be 3 seconds. So let's get another one of those where we're trying to find what height it makes. So how about this guy, V0 t, take away 16 t squared, and the initial velocity is 128, and we're being asked to find when is its height 100, when is its height 96. Okay, so it's going to be 128t, take away 16t squared, and we're going to solve when is it equal to 96. And that's going to be -16t squared plus 128t, take away 96 equals 0. And the reason I want to choose this one is typically you would get 2 solutions. Normally the thing goes up and it goes down, and you pick a height like 96 feet and you get 2 solutions. The one that we did here, it goes up, it goes down, and we actually only got 1 solution because that was the height where 144 was, right? So there was only a single value. But this one should generate 2. So I'm not going to try and factor it, it's just impractical. So I'm going to use the quadratic formula with very messy numbers. I'm going to calculate the b squared take away 4ac part. So I always do first. So it's going to be 128 squared, take away 4 times this guy times this guy. (128 squared), subtract 4 times -16 times -96, and the answer I get is a really big, ugly number, which is fine. So what does our solution look like? Our solution is t equals -b plus or minus the square root of b squared take away 4ac all over 2a. The negative of this guy is negative 128. Add or subtract the square root of 10,240, and the whole thing gets divided by 2 times this guy, which is negative 32. Now, although that is ugly, and it certainly is, the calculator is going to do most of the heavy lifting. So here are the two solutions. It's negative 128 plus the square root of 10,240, all divided by negative 32. And the other one is negative 128, take away the square root of 10,240, all divided by negative 32. And both these calculations are going to be done in this guy. So put a bracket around the top. So start with a bracket. Hit the negative button, negative 128. Add the square root of 10,240. Close the square root and then close the top bracket. Then just divide by negative 32, and the answer we get is, to 2 decimal places, 0.48 seconds. Now, you want to do the second calculation? Start with the bracket. Negative 128, subtract the square root, close the square root bracket and the other bracket, and then divide by negative 32. And this time you get the second answer, which is 7.16 seconds, and everybody is happy. So that particular group of application questions, I think, would fall into the category of, we know the position of an object, we have a formula for it, it's a quadratic formula, and we're either trying to solve when is it equal to 0 or 96 or some given value. Right, our next puzzle question is going to be similar to question 3. And this one is to do with objects moving, right? Traveling, journeys, if you prefer. So in this case, a cyclist traveled 60 miles. So just write down the details. Traveled 60 miles. So imagine from there to there, 60 miles. Okay. And they did it at a constant rate. Before reducing the speed by 10 miles an hour. So you then reduce the speed and you traveled another 40. And what you're told is that although you weren't told what the speed is here, you know that the reduced speed was 10 miles an hour. Less. Okay. You're also told the total time. So the total time of this journey, which is what, 100 altogether, was 7 hours. And we're being asked to find the speed during the first part of the journey. So this is the first part of the journey. I guess I'll call that the second part of the journey. So we've got a lot of information that we'll have to somehow put together. And the first thing I'm going to do is, let's do the speed of the first part of the journey. That's this distance here. If you don't know something in math, you can call it x. Now the speed of the second part of the journey, which is this one, I don't know what number it is, but I do know that it's 10 miles an hour less than this guy. So if this guy is x, the second one was going at a speed of x minus 10. Now, if you want to calculate the time that a journey takes, it's the distance divided by the speed. And that's for the first part of the journey. And then the same formula, the distance that you traveled divided by the speed. We'll call that the second part of the journey. So what do I know about the time? It took 7 hours. What is the distance? The distance is 60. What speed did you go? You went X. What's the second part? Well, the distance you travelled was 40. What was the speed you went at? And the speed you went at was X minus 10. So this is the equation that we're trying to solve. What's the problem with this equation is that it is definitely not looking like a quadratic. But on the next couple of days, I'm going to be showing you some more examples of how to deal with rational equations, because this is basically a fraction equation, right? A rational equation. So let me show you the process on a new piece of paper over here. We're going to use a strategy that we've used in solving many different kinds of equations. My fancy name for it is, as long as you do it to both sides, it's okay rule. Now, if I multiply both sides, right, all of this and all of this by just X, this guy, 7 times X. If you multiply this guy by X, you get 60. And if you multiply this guy by X, you get that. Now, what I'm going to do now is I'm going to multiply both sides by X take away 10. So this fella becomes 7X times another X take away 10. This guy becomes 60 lots of X take away 10. And this guy becomes 40X. So what I've essentially done is I've taken this equation, and by multiplying both sides by X, and then after that, X minus 10, or if you want to, you could do it in one go by multiplying both sides by X, X minus 10, we get to this. Now, this is a quadratic equation. We just have to do a bit of work. If you distribute, you get that. If you distribute, you get that, and you get that. Now, I'm taking this nice and slowly. So some of the steps I'm doing here, you might basically just combine them into one big step. But I'm adding the 60 and 40x together. I'm now going to subtract 100x from both sides. Right, 100x from both sides. That gives me 170x. And I'm going to add 600 to both sides. And I'll just write this guy again because he's a bit messy. So if you want to solve a quadratic, get it into its standard form. That's its standard form. I could try and factor that. I doubt very much it's going to be even doable. I mean, you may get lucky and find a factoring. Since I don't really hold out much hope that I'd be able to factor it without a lot of luck and a lot of trial and error, why don't I just do the quadratic formula? So let's get the b squared minus 4ac bit calculated. Negative 170 squared, take away 4 times 7 times 600. So on our calculator, put a little bracket around it, negative 170 squared. Take away 4 times 7 times 600. And we get 12100. So x is negative b plus or minus the square root of b squared take away 4ac all over 2a. That's going to be the negative of this guy is positive 170 plus or minus the square root of 100, that thing there, all divided by 2 times 7, which is 14. So at this point, I'm going to split it into its two pieces. One of the solutions is 170. Take away the square root of that guy, all divided by 14. And your other solution will be this guy, also over 40. Let's see where this goes to. If you take this guy, it's 170. Take away, I think that's going to come out as a nice number. Let's find out. Square root of 120,100 is 110. Which is 60 out of 14. I should be able to simplify that down. 60 divided by 14. Yeah, make it a fraction. It's 30 cents. Try this one. 170, add 110, all over 14. That gets me 280 over 14. This guy gets me, oh, this guy gets me 20. Now, if I turn this guy into a decimal, I want to show you why I can't use it. It is roughly about 4.3 miles per hour. And this one is 20 miles per hour. And the reason why I'm going to throw this one out is, if you remember right at the start, the second part of the journey, this bit, was whatever this speed is, but 10 less. If you take 10 miles away from this, do you see that you get a negative miles per hour, which doesn't make sense? So there's only one solution, and there it is, that you go 20 miles per hour for the first part of the journey, and then the second part, you only go 10 miles an hour. So hopefully you can take some time and maybe slow it down and pause and watch what I've been doing. Take it through. So our next one is going to be similar to 4. And this is another journey story, so I'll just read it out to you. The United States Air Force uses the designation VC-25 for the plane in which the President of the United States flies. When the President is on the plane, it's called Air Force One. The police speed in Carmel, right? So here's my little picture of my plane. If there's no wind, the speed of Air Force One is 630 miles per hour. I mean, I know it can change, but let's say that's its optimum speed that it typically flies at. Now, this plane traveling at that speed, we're then told it can fly from Washington, DC, and it can fly to Cairo, which is in Egypt, and that's a distance of 5,820 miles. It's a long journey. And that distance that it travels, it also returns. And this is where it gets messy. There's a wind blowing. It's called a jet stream. And what we're told here is that on the way back, it travels 4.13 hours less than when it was going the other way. So I want you to imagine then that the wind is blowing that way. I'll call the wind X. So if you're going from Washington to Cairo, your true speed is actually made up of two numbers. It's the 630 that the plane is going to fly at, plus the extra push of the wind. When you go the return journey, you're flying against the wind. So your speed isn't just 630. It's 630 take away the headwind. So we know two different speeds, and what we know here is that the difference between one and the other is 4.13 hours. And from that, we should be able to, and we're being asked to find what x is. So a lot going on here. I know the speed going from Washington to Cairo. I know the speed going from Cairo to Washington. They both have x's in it. I know that the difference between the two times is really awkward, 4.13 hours. And evidently that should be enough information for us to solve x, the wind speed. Well, let's figure out how to do that. I know the time is basically your distance that you travel divided by your speed. So if I want to do from Washington to Cairo, the time of that journey is going to be the distance 5820 divided by the speed, and the speed is 630 plus x. And if I'm going from Cairo to Washington, the time will be the distance that you travel divided by its speed. And its distance is also that, but your speed is going to be that guy. I know that this one is the bigger one of the two, and this one is the smaller of the two, even although I don't know what x is yet. Since everything is the same except that's a plus x and that's a minus, because that's a plus, this will be bigger. And if you divide by a big number, you get a small answer. Why is that important? Well, I'm now going to use the fact that I know the difference in times. The difference in time is 4.13 hours. And the difference in time is going to be this guy, the big one, right? The time it takes to go the slow way, if you like, take away the small one. So I now have 4.13 equals that guy take away that guy. And we have now got one of the really ugly equations to deal with. Probably this is the worst question in the whole set. So you might think, well, how are we going to solve it? I am going to multiply both sides by 630 minus x and by 630 plus x. Show you what happens. If you multiply both sides by 630 take away x and by 630 plus x, you do it to that guy, you get this. You do it to this fraction, all you get is 5820. That'll cancel and you'll just get that guy. Take away 5820 times 630 take away x. And this here is no longer a fraction. And this here is eventually going to be a quadratic. And it is not going to be a pretty quadratic, but nonetheless it is going to be a quadratic. So 4.13 times whatever that comes to. Let's figure out what this is. 5820 times 630 gets me 366. 1, 2, 3, 4 zeros. Take away, plus I should say, 5820x. If you do this one, you're going to get minus 3666600 plus 5820x, which is kind of nice because they cancel out, and all you get is 5820 times 2, so you get 11640x. If you multiply this guy out, you will eventually get 396,900. Take away 1260x plus an x squared. And then I'll distribute the x's. I will get 4.13x squareds. Take away, let's do 11260 times 4.13 times that guy. And then finally 4.13 times 396,900. 4.13 times 396,900. There we go. 1639197. If you then subtract this from both sides, you will get 4.13x squareds. Let's put this guy together. We have 5203.8, take away 11,640. So you're going to get negative 6436. Okay, just looked weird. That guy. Plus 1,639,197 equals 0. If you make A 4.13, if you make B negative 6436.2, if you make C 1 million and change, and you plug it in to the equation, you will get one solution that makes sense, which is this one. The other solution doesn't work because it's a negative x, and we're not allowing negative x's. God, that was an ugly one. So you'll be glad to know that the next one is a lot easier. In fact, let me show you. Well, not actually, I don't need to show you. I can just draw it for you. In the next question, you start off with a rectangle that looks something like this. And in this rectangle, you're told that this here is W. And you're told that this distance from here to here is 8 more than it, so it's W plus 8. And then they cut little corners, 2 centimeters each, little square corners. And if you cut the corners up, you can fold it into a box. And your box would look something like this. And we are being asked that we have to find the dimensions of that box. So basically how long and wide and tall it should be. So we're being asked to find its length, its width, and its height. When you're told that the volume of this box is 210 cubic centimeters. Well, if you imagine this box being folded, its height is going to be 2 centimeters, right? Because the little corners. This guy here, the width of it, the box, is going to be this distance from here to here. Right? Imagine the corners being folded up. Put little dotted lines in if that helps. If you bend it along the dotted lines, do you see how the width is now going to be W take away 2 lots of 2? And this guy is W plus 8, right? The total distance. But that distance is what you get in the box here. And so what's that? W plus 8 take away 4 gets you W add 4. So I can now find the volume. It's length times width times height. It is a length of W plus 4. It's a width of W take away 4. And it's a height of 2. And we're told that this is equal to 210. So FOIL this guy out. You get that. Divide both sides by 2. You get that. Add 16 to both sides. You get that. And take the square root of both sides. Now, technically, you should do a plus or minus, but negative 11 is not a good idea. So we know W is 11. So what do I know? Well, I know that W is 11. So let's find out what the length, the width, and the height look like when W is 11. Well, the height is 2. Actually, it's always 2. The width is W take away 4. 11 take away 4 gets you 7. The length is W add 4. 11 add 4 is 15 centimeters. And there's the solution. That was a lot nicer than that horrible aircraft one. Only got 2 more to do in question 6 then. A dog trainer has 88 feet of fencing and he's going to use it to create a rectangular work area for his dogs. Okay, so rectangle, fence, gotcha. He has 88 feet, so the total length, right round the outside, is 88 feet. We're also being told that the area, right, the area of this is going to be 448 square feet. And somehow or other, we have to find out what the length, right, what are the dimensions of our work, right? What's the length and width, in other words. So I'm going to call this distance from here to here W. That's her width. I guess I'll call it L. L for width. And I'll call this distance here W. Now, since the total length is 88, I know that 2 L's plus 2 W's would make up the 4 sides, and I know that's equal to 88. And that means twice times the length is 88 take away 2W, and that makes the length, divide both sides by 2, 44 take away W. That's going to be important later on, that the length is 44 take away W. Now, I also know what the area is. The area is length times width, and we've been told that's 448 feet. And I'm going to replace the length by this guy. So 44 times W, which is what the length is in terms of W, times W is 448. You distribute. You get that. If you subtract 448 from both sides, you now have a quadratic equation. And you can solve that by factoring if you want to. You can solve it by the quadratic equation. When you do it, you will find out that W ends up being 16, and that the length, which is 44 take away 16, ends up being 28. And so the width is 16 and the length is 28. And that's the end of that question. So we're on to our final question in applications. A car with a good tread can stop in less distance than a car with poor tread. Okay. The model or the formula for how far it takes to stop, B, is given by 0.04 v squared plus 0.5 times v, where v is the velocity of the car just before you hit the brakes. We are being told that if you want to be safe, right, then the distance that you need to stop is 45 feet. We're being asked to find what is the velocity, what's v, when the stopping distance is 45 feet. Now, they can actually use something similar to that. Imagine that you turn up, you're police and you turn up at an accident and you're trying to discover what speed the vehicle, let's say it's a single vehicle accident is. Well, very often when you hit the brakes, you know, they're going to be, you know, the skid mark on the road. So you can start where the skid mark is, and let's say it finished at 45 feet because that's when the car stopped. And you want to find out what speed that car would have to be traveling to stop between 45 feet. Right, so imagine that's our story. So we'll start with our formula, which is definitely going to be using the quadratic formula. There's no way I'm going to factor in when it looks like that. You tell me that's 45, and now we're going to find out what v would equal. In this case, subtract 45 from both sides, and you've got that. It's in its standard form now. A is the coefficient of the v squared, which is that. B is the coefficient of the v, and C is the constant term. We'll then calculate that guy first. He's going to be 0.5 squared, take away 4 times that guy, times negative 45. And on my calculator, that's going to be 0.5 squared, take away 4 times 0.04 times negative 45, and that is 7.45. So our equation is going to be v equals negative b plus or minus the square root of b squared, take away 4ac, all divided by 2a. So it's going to be the negative of that guy. So negative 0.5 plus or minus the square root is 7.45, all divided by twice this guy, which is 0.08. And at this point, I'm going to split it into its two solutions. Negative 0.5 take away the square root of 7.45 divided by 0.08. And the second velocity could be negative 0.5 add the square root of 7.5 divided by 0.08. Right, let's see what this one is. It's going to be one of those questions where it's a good idea to put a bracket around it, so I shall do that. A bracket, negative 0.5, take away the square root of 7.45, close a few brackets, and then divide by 0.08, and the answer I get is negative 40.36 miles per hour. And I'm immediately going to kill that one, because we're assuming that the car is traveling forward, so velocity must be positive. Let's see what this one is. Put in a bracket, put in a bracket. Negative 0.5, add the square root of 7.45. Close a couple of things. Divided by 0.08, and the answer I get is 27.86, or to the nearest whole number, 28 miles per hour. And that is, yeah, you weren't breaking the speed limit. Let's say the speed limit was 30 miles an hour. So at least you wouldn't get a speeding ticket, or at least if they tried to charge you for driving too fast recklessly, it wouldn't hold up, because this formula basically proves that you were traveling at a reasonable speed when whatever accident occurred. That's what happened. So watch this space. I'm going to be doing over the next couple of days some more examples of rational expressions and how you can solve them. You know those fractions, equal numbers that turn into quadratics, for instance, we're going to concentrate on doing some more of those. And so hopefully you'll get a little bit more practice at that. We'll also be looking at solving other types of equations and applications that have fractions in them. But that is for a later date. Remember, and I'll try and do this at the end of every video, that your final is this Thursday, the 18th. It's going to last you 3 hours. It's going to be on WebAssign, and you need to be aware that you have to start at least 9 p.m. Earlier would be better in order to finish on time. So clear the decks and get ready. Get plenty of practice for your final. If you want to do well, the final is worth 30% of your grade. It's going to cost you a lot of points if you're not prepared. So goodbye for now, and I shall see you tomorrow.